So now we're going to take a look at converting vertex form to standard form. So you'll recall that in the last unit, when we did quadratics 1, we worked almost exclusively with the equation that you see here just to the left. Okay, and this is known as the vertex form of a quadratic equation. The vertex form of a quadratic equation is called that because the vertex is given to you by the hk values. That's the coordinate of the vertex. And it's a very useful form of the quadratic equation. It gives us lots of good information, but it doesn't give us everything right off the bat. And so sometimes we want to use a different form of the quadratic equation that we call standard form. And we can use standard form of the quadratic equation, which is right here, just to the right. And this particular form of the quadratic equation is really, really useful because if you have a parabola in standard form, you can automatically see what its y-intercept is because its y-intercept is the same as the c value. So what's important to know is that you can convert vertex form into standard form and they mean the exact same thing. Okay, and they represent the same parabola if you were to graph them. So let's go through and take a look at how do we convert from standard form. So in our example, we've got y is equal to x plus 4 all squared minus 5. And this is given to us here. This is in vertex form. So again, I'm going to write that out. Y equals x plus 4 all squared minus 5. Okay. Now, this is vertex form, so I'm just going to quickly put a VF beside it. Okay. Now, what's important to know about this equation is that there is a binomial in it. In fact, there's a perfect square, and that perfect square is located right here. Okay, so where you have x plus 4 all squared, you can rewrite that just like we have done when you're talking about multiplying out using FOIL. So I'm going to do that right now. I'm going to do y is equal to, and I'm going to put a larger bracket here. That's x plus 4 times x plus 4. Okay? So I've just expanded that piece out, and that minus 5 at the end still has to be there because we haven't dealt with that yet. So what I'm going to do now is, now that I have two binomials in this equation, I'm going to multiply them using my FOIL pattern, just like we had learned to do in the last lesson. So I'm going to go and multiply that. Whoop. I'm going to go and multiply that now. So that's going to give me, oh dear. That's going to give me y is equal to x squared plus 4x plus 4x plus 16 minus 5. Okay? So then I've got y is equal to x squared. I'm going to collect my like terms. So I'm going to take the 4x plus 4x, and that gives me 8x. And my plus 16 minus 5 is, positive 11. Okay, so now I've just gone through and I've converted from standard form, from vertex form into standard form. So the reason why standard form is so helpful is that I now know, based on this c value at the end, that my y-intercept is actually positive 11. Okay, so my y-intercept equals positive 11.